Hello, everyone. Welcome to our weekly workshop. So, this is the fourth workshop in our weekly series. And today we will be dealing with the classification. So, before I start, I see lots of you are like new. So, how many of you are new? Like this is your first session. All right. So, so far we have covered data cleaning, data pre-processing, feature engineering, and how to generate features from a text data. And in this series, we are trying to build an event recommender system. So for all of you who are new, I'll try to make things simple so that you will understand today's session. And you can get a recording and all the code and PPT from our previous workshop. So just right after the workshop, contact our team and they will be able to provide you with the necessary resources. I expect all of you are joined in our Discord series, like Discord server. So in the Discord, for those of you who haven't joined, let me give you a link. I don't think I have it. How many of you are not there in the Discord channel? Quite a few. All right. Just allow me some time. All right. This is not visible, right? Let me. This is not visible. All right. So this is the link. Please try to join the Discord channel. All of you join the Discord channel. All right. So let me put the links. So there should be a link in the machine learning channel. Please download the collab file. Please try to use your ASU ID. All right, just give me a second. Now you should have the access with the ASU ID. अच्छी है. So for this workshop series, we use Google Colab. I'm sure most of you are aware about the Google Colab. It's a pretty simple cloud-based platform where we can code in multiple languages, including Python. So right after you download the Colab file from the Discord channel, please upload it into your Google Colab account. And for those of you who are new, you can just type Google Colab on your browser. Hit the first link. There you can upload your file from here. And the file should look something like that. And there are two links available for the dataset we are going to use for today's workshop. So please download those two as well and upload those into your Google Colab by hitting in this icon. And here you can use this upload tab and then upload the dataset. Anyone still left to download the data file and the code? Yes, please. All right, so I'll start the workshop. So this is the fourth workshop from our series. And in last workshop, we have covered feature generation from text data. It was part of natural language processing. But since we are trying to build a event recommender system for ASU events, for that, we need to learn about text data because all the events data is available in text format. So even though this is a machine learning workshop, we will be learning a little bit about the NLP as well. And in today's workshop, we will start with machine learning. What is supervised? What is unsupervised learning? Then we will see what is classification. What are the classification algorithms? And then we will see the performance metrics for the classification task. And if you have any doubt, just feel free to ask. Right. So here is a quick recap from last workshop. So we covered feature generation from text data. So In order to generate features from text data, we need to follow certain steps. The first step is data cleaning. So we need to remove all those unnecessary words which does not contribute uh, to the meaning or the context of the information. Uh, so in the last workshop, we covered removal of stop words. We removed some of the digits. We removed mentions, HTML tags. And this data cleaning is highly subjective and it depends on our objective and the nature of data. So in last workshop, we covered that uh, let's say we have a financial data, there removing all the numbers from the data is not a good idea. But for our task, it does not add any value uh, because usually all the dates and time is also available in our data set in the date time column. And after that, we perform tokenization. So tokenization is nothing but converting those words into separate token so that later we can assign individual numbers to those words so that the machine can understand, because machine only understand numbers. Every machine learning algorithm works on numbers in the end. And we didn't perform this step because we generated features using TF-IDF module, which is available in the scikit-learn library in Python. And in that function, this tokenization step is built in. So that's why we don't need to explicitly perform this step. So for generating the features, we used the simplest algorithm, which is TF-IDF, term frequency and inverse document frequency algorithm. And there are other ways to generate features as well. For example, this n-gram model, which is usually there in the like LLM and all. So what is TF-IDF? So basically, we find the term frequency and the inverse document frequency, and then later on, after multiplying the two, we get a number, and we expect that that number would represent the importance of a particular word in a given context. So it's pretty easy. If you see here, there is this example. There are two documents. One is Jupiter is the largest planet, and in the other one, it says Mars is the fourth planet from the sun. And calculating the term frequency is pretty straightforward. We just find individual words and we just find their frequency and divide by the total number of words. So that is the term frequency. The other term is the inverse document frequency. So what it does, it finds basically it's a logarithmic scale, and the formula is right there. It says log of total documents divided by 1 plus number of the document containing that particular word. So here if you see that is and these are the words which does not add any value. And in the inverse document frequency, the inverse document frequency is 0 for those two. So this method is simple yet really effective because this captures the importance of a word and discount all the unnecessary words which are often used. So let's say in a normal conversation, we use hello, hi, these kind of words very often, but they do not add to any value. So even though this has some advantages, there are some disadvantages as well. So the limitation is, of course, the context. Since we are just using the words as separate tokens, it does not have the understanding of the context. That's why other models like Ngram, they are way better in understanding the context. So far, that was all covered in our previous workshop. Today, we will start the machine learning. And for those of you who have made this far, congratulations, because we have done quite a lot of pre-processing, data cleaning, and then handling the text data. Finally, we are getting closer to our final project, which is making an event recommender system. So today we will start machine learning. What is machine learning? So according to IBM, machine learning is a branch of artificial intelligence and computer science that focuses on using data and algorithms to enable AI to imitate way that human learn. Well, this is all the fancy definition. In short, machine learning is uh, a program, you can say, that is trying to learn or it is able to perform a task for that it is not programmed. And one very important aspect of machine learning is the more the data you provide, the better the model will be able to learn and perform the task better. So there are two kinds of machine learning, you can say. One is supervised and the other one is unsupervised. Feel free to stop me if you have any doubt or if you feel that I'm going a bit faster, just let me know. All right. So for the supervised learning, as the name suggests, it's nothing but training the model based on the labeled data. So what is labeled data? So let's say I have two kinds of emails. One is spam and the other one is not spam. So I have labeled that this email is a spam and this other email is not spam. Similarly, I have bunch of emails which are labeled as spam or not spam. And then I'm asking my machine learning model to learn that this email is a spam and this one is not. So I have provided the label, which is like spam or not spam. This way of training the machine learning model comes under the supervised machine learning. And of course, for that, we need to have a labeled data. Otherwise, we cannot perform the supervised task. And some of the examples include linear regression, logistic regression, decision tree. These are machine learning models which comes under supervised learning. The other one is unsupervised learning. So for the unsupervised learning, we don't have the label. So what we try to do, let's say I have a bunch of images. One is of dog and the other one is, let's say, horse. So for those two images, I am not telling the machine learning model that this image belongs to a dog or this image belongs to a horse. Rather, I am expecting the machine learning model to learn all the patterns and being able to distinguish between the two. Even though the model does not know what horse is or what dog is, how it looks like, it should be able to determine the difference between the two. And an intuitive approach could be, let's say machine learning model is trying to figure out patterns like, uh, so the horse is usually bigger than the dog and the face structure and let's say the legs to the body ratio, these are different for dog and horse, right? So I'm not saying that this is exactly what the model is doing, but the machine learning model in unsupervised learning try to figure out patterns to distinguish between two or multiple things. So that kind of task comes under unsupervised learning. Even though if you don't understand this clearly, it's okay, because after covering classification today, in next workshop, we will cover some unsupervised learning models. After that, the difference will be clear to you. All right. So moving ahead, for any machine learning task, this is the life cycle we follow. There are additional steps as well. So the first and the very important is data gathering. So in our first workshop, for those of you who have attended that, remember that we got our data by web scraping the ASU website. So we already have the data. Later on, we perform the pre-processing, and these steps are true for any kind of task and machine learning model, like all kinds of project. This is true, regardless of supervised, unsupervised, classification, or any other task. So the second step is data pre-processing. And for the data pre-processing part, we have covered the data cleaning, the data normalization, feature engineering, and other things as well. And the third one, today we are going to cover the modeling. For the modeling part, we implement a suitable machine learning model and try to tune the parameter so that we get a better accuracy. So every data is different, and depending on the nature of the data, the type of data, it might be that a particular model is performing good with one data set and not performing poorly on the other data set. So for that, we need to understand the type of data, and based on that, we choose a suitable, I would say, model, and then implement it. So this step comes under modeling. Later on, we can test the model, how well it's performing, because without that, it just everything is in blank, right? You have trained a machine learning model, but you don't know how well it's performing. Then it's useless. After that, you can, depending on the type of the project, the last step comes is the deployment. All right. So today we will be learning about classification. So classification comes under supervised learning. So what is classification? So classification is a type of supervised learning algorithm where the goal is to predict category labels. So what does it mean? So imagine you are at a party where the task is to divide people in two groups, where one group is wearing hats and the other group is not wearing any hat. So this is nothing but classification. You are classifying all those people into two groups. There could be multiple groups as well. So this is nothing but classification. So some of the examples are email spam, as I have mentioned earlier. So as a email could be spam or not spam. So this is a binary classification where we are trying to classify the email in two categories. One is spam, other one is not spam. There is this medical diagnosis where maybe the goal is to predict or classify disease or not disease. Similarly, you can use image classification where the goal is to classify the images of dog, cat, and rabbit. So if you notice in the other two tasks, we are classifying into two groups, but in the last one, we need to classify in three categories. So this is called as multi-class classification. So there could be more than 3 or 4 or 5 groups we are trying to classify. All right. So support vector machine. Support vector machine is a machine learning algorithm. Basically, it was designed for classification purposes, but it can also be used for regression tasks. We haven't covered the regression because of the nature of our data and the time constraint we had. But you can also go home and learn about it. If you feel any doubt, there is this Discord channel available. You can ask doubts as well. So coming back to support vector machine, it is a supervised machine learning algorithm uh, that classifies data by finding the optimal line or hyperplane that maximize the distance. So what does it mean? So basically, if you see over here, there is this picture, and over there, we have plotted all those data points. So all these points are nothing but data. So let's say you have a house data, and for the house data, you have two kinds of information. One is the number of BHK, the bedroom and all. The other feature is, let's say, the land area. So we have plotted those two features over here, and we have two kinds of house. So if you see, there are two coloring scheme. The blue represent a different class, while the yellow represent another class. So if this is how our distribution of data points looks like, graphically, we can tell that if I draw a line between the two, anywhere over here, and then if I say that this side of the line belongs to, like, all the points who are on this side of the line will belong to this class 1, let's say, while all the data points which are on the other side of the line will belong to the class 2. It seems very easy, right? Any doubt so far? All right. But this graph is only valid for two-dimensional data set. but often we always have more than three, four, five, or sometimes even 100 features. And we humans cannot visualize more than three dimensions. So that's why. Uh, so any line in a higher dimensional space is nothing but a hyperplane. So let's say we are talking about three dimension. So in three dimension, this room is three dimensional, right? And uh, if I draw a wall, let's say over here, so I have divided all of you between two groups. So for three dimensional space, the line I am using, I can no longer use the line. Instead, I need to use a seed, a two-dimensional seed, right? Like a wall. So this is the core idea behind the support vector machine algorithm. Um, so just understand that it's nothing but we are drawing boundaries. So if you haven't understood anything, what I have told you so far about SVM, just remember that SVM is the algorithm which draws boundary between the different classes of data points, and because of that boundary, we can classify all those data points. So this is a supervised machine learning algorithm we can use for a classification task, and this is the algorithm we will be implementing today. All right. So SVM uh, is pretty robust, and it can classify binary class or multi-class as well. And you can even imagine, so let's say you have some data points over here. You can like draw maybe, let's say, two lines, one over here and another one over here. And then you will be able to determine, like classify three classes. So this is a very robust algorithm. And so, so far I have been talking about the line. So this is a linear model, but there are other ways we can draw even non-linear boundaries, and that is known as kernel tricks or kernel functions. We won't go much in detail about those, but just remember that this machine learning algorithm is pretty robust, and it is not limited to classification or regression, binary or multi-class classification. Also, we can use this algorithm to draw non-linear boundaries as well. So there are other models as well for binary classification. Like SVM is pretty robust; it can be implemented in either. Even decision trees are can also be used for multi-class as well. And we have random forest, naive Bayes, and KNN. So these are some of the algorithms. You can go home, look into all these algorithms over internet, try to implement those. If you feel any doubt, you can ask us on the Discord channel. All right, so let's come back to our hands-on. I expect that all of you by now have this file. This is nothing but a Jupyter file. And these are the two dataset links which we are going to use. Um, so this dataset is similar to what we have generated till the last workshop. We have covered, like, we have generated TF and IDF features based on the description and other features. So this is the same, but we have cleaned the dataset further. So this is a new dataset, not exactly the one we were using, but it's similar in terms of the pre-processing we have done so far. So we will start with importing all the necessary libraries, just like our previous workshops. Then we can load our dataset. Since we have two datasets, we will be loading the two. We can assign different names, whatever we like. So this one I would like to call data. Wait a second. So my drive is not linked with the notebook file. It's fine. So So this is how our data set looks like. Wait. All of you already have the dataset and the notebook file. You can try to run these cells, or if you feel you have any doubt or you are not able to understand anything, just feel free to ask. So this is the dataset. This dataset contains the TF-IDF feature, which we have generated in the last workshop. So we will be using this dataset for the training purpose. And we have this another dataset. Wait. All right, so this one. So in the different data set, we have three columns. As you can see, we have 1,413 rows and three columns. So these three columns are the features. And we will start by separating our features and target variable. So what is a target variable? Since this is a supervised machine learning algorithm, so the label which we are trying to predict, we call it the target variable. So let's say we are classifying emails into spam or not spam. So what will come in the target variable? Exactly. So it will be a 0 or 1. And we could say that 0 represent that this is not spam and 1 means that this is a spam email. So that is the target. So we are basically telling that this is the data and this is the target. So you need to learn the relationship between the two. And this is because this is a supervised machine learning algorithm, we need to provide the target variable. So here, if you see in this code, the TF-IDF features, I have set it with the X variable and the target, which we usually denote with a smaller y. You can use any notation if you want. I have assigned it with this another data set with the theme column. So if you remember in our previous data set, we didn't have any theme column. So this is like a new data set, but still the pre-processing and everything is the same. So in the theme, we have 6 to 7 different theme, which we are trying to predict based on the information which is available in the event description column. Right. So now let's come to one-hot encoding. Before I start one-hot encoding, if you have any doubt so far, feel free to ask. Any doubt? All right. So what is one-hot encoding? So one-hot encoding is a technique used to convert the categorical variables into numerical format. And the reason we are performing this step is because, again, the machine cannot understand text. It only understands number. So let's say I have three categories. For example, I have apple, chicken, and broccoli. So these are three categories. So I can call this category number 1, category number 2, and category number 3. And what I can do is make the machine learn and predict that, let's say for any data, this is the apple, and this is the chicken, and this is the broccoli. And I have assigned number 1, 2, 3 to represent these three categories. But there is an issue with that. Anyone would like to answer? Why we cannot use this kind of notation where we are assigning number 1, 2, 3 or any three random number to the categories so that the machine can distinguish that these are different categories.
Right. Like if there are more, example, one more mutton, so
Right.
bacon. So we have to add one more thing so that numbers goes on increasing, so that it will be difficult for us to.
Well, yeah, if we add another category, then our number will increase. But that's pretty convenient, right? I can just increase the number by 1 every time I have a new category. So what's the flaw? Yeah. Uh, Not really. All right. So this kind of encoding is not effective. And the reason is because the machine understand only number, but here we have assigned number 1, 2, and 3. But these are just symbols, right? One represent a particular class, two represent a different class, while the number three represent another class. These are not the numerical number we understand. What the machine will say that 1 plus 1 equal 2. That's why an apple plus another apple should be equal to chicken. Which is not true, right? That is why we use one hot encoding. And it's pretty simple. The way it works, so it basically it generate three features for the three categories, and it will say for the apple, I will say 1 and 0, 0 for the chicken and broccoli. In the similar fashion, so in this notation, I'm only using the number 0 and 1. And since I have generated additional features, the machine will still be able to identify individual category, and it will not face the issue what we have covered, like 1 plus 1 equals 2, or let's say 2 plus 1 equals 3. So apple plus chicken is not equal to broccoli. But in this case, it's only 0 and 1. And the way we implement one-hot encoding is pretty simple. We can use the sklearn library. This is also known as the scikit-learn, which we have used so far. And there is this label encoder and one-hot encoder. These are built-in function available in the library. And for those of you who are new, this is a library which is basically used for machine learning purposes, and it is available in Python language. So we are using Python and the scikit-learn library. So you can import the label encoder and assign a name. Here I have said LE equals to label encoder, and then I can fit and transform. I can use this function fit transform for the target variable, and the target variable was theme, right? So what it will do, it will basically generate this in the similar fashion, these different features for all the theme we have available in the data set. So far, we have cleaned the data, performed all the necessary pre-processing and everything, generated our features, and we have set the target variable, and we have performed the one-hot encoding, it's a label encoding. Now it's the time that we split our data set into training and testing. Yes.
Why are we doing label encoding in the end? Shouldn't we do one more encoding?
Yeah, we should be doing the label encoding. I think there is a typo. I have used the two for demonstration purpose, but somehow that got removed. We will fix it right after the workshop, so don't worry about it. So now we will split our data set into training and testing. What does it mean? It means that we will divide our data set and we will use a majority of the data set to train the machine learning algorithm, but still we need to test it, right? The one way to do it is we can use all the data we have available and feed it to the machine learning model for training, and then we can use the same data set to check if the machine learning model is performing good or not. But there is an issue with that as well. Since the machine learning algorithm have seen all the entire data, it will be able to predict accurately. But every time the machine learning model will have a new data set, it will perform very poorly. So this is nothing but overfitting. You can read about it as well. I highly recommend it. So a standard procedure is to divide our data set into 80-20%. So it's pretty simple. We will use 80% of our data to train the machine learning model, and we can use the rest of the 20% data for the testing it. And the way we do it is, again, we use the scikit-learn library, And in the model selection module, we have this train test split function available. We can use it. And what it does, since this is a supervised task, uh, we need like testing and training data. At the same time, we need features and the target variable. So it returns four output, and we will call it X train, X test, Y train, and Y test. The naming is pretty standard. All right. Since now we have prepared our data, and the only thing which is left is to implement the machine learning model. Since we are going to use the SVM, this is also available in sklearn library. So from sklearn.svm, we are importing SVC because it's a multi-class, like it's a classification task. So that function is known as SVC, but still we will call it the support vector machine because that is the algorithm. This is just the naming scheme. And we can initiate the model by writing this line. Then we are saying that this is the name of our model. We can use any name we want and setting it to the SVC. And here, if you see, we have two different parameters. The one is kernel, which we have talked about in the initial slide. And the other one is the decision function set. Don't worry much about it since we are using, we are predicting like a multi-class label. That is why we are using the OVR. The OVR stands for 1 over, I'm not sure, but it basically labels one-to-many relationship. You don't need to go into much detail about that. So right after initializing our SVM model, we can feed it with our training data. And the way we train our machine learning model, guys, please pay attention to this step. This is very necessary step. It's pretty simple. We will say that SVM model dot fit. This is a function built in available, and we will fit the X train and the Y train. Basically the target and the feature data, and this is nothing but the training data. So right after this step, our machine learning model is trained. Yes.
If it's only a two-label classification, what should be the decision function?
You can ignore it because it will be OVO, which is by default. So even if you don't mention anything, it will be like that. And for the kernel, I'm using linear because I believe our data should be linearly separable. We can experiment with different kernel like Poly, RBF. You can go on Google and learn more about it. But for those of you who are really new, just don't worry much about this kind of thing. Just focus on the basics. Like what is SVM, why we use it, how it works. That's all you need to know so far. All right. So now that we have trained our machine learning model, it's the time that we test it. And we can use, we can predict the, so what we can do for the testing, we will use the testing data, which we have split initially. And here, if you see, let me scroll a little bit. So here you see, we had like X train and Y train, which we use for the training purpose. And we are left with the X test and the Y test data. So what we will do is, basically we will predict using the model, and we will feed the test data, and we will save all those predictions the model have made into a different variable, and we will call it Y pred, or you can type whatever you want. So now I have the model prediction for the 20% of the data. At the same time, I have the true values for those data points, which is stored in the Y test variable. Now I can compare these two to evaluate how well our model has performed. So for the performance metrics for classification, we have different kinds of metrics we will use. So what metric is? Metric is nothing but you can say a set of formula or a set of number which can represent how good our model is. But since a particular number, like a set of scale or a particular metric cannot represent all the details which is going on into a machine learning model. So we have several different performance metrics available to us, and we will cover all those. So the most basic and fundamental is accuracy. So what is accuracy? So accuracy is nothing but I will check that, okay, for email, I had spam and not spam. And what I will do is I will add the numbers, like all the emails which were spam and correctly predicted as spam. And I will add with all the emails which were not spam and correctly predicted as not spam. So, and then I can divide all this number with the total number of data point I had. So it will basically give us a score, which we call accuracy. And it will tell us how good our machine learning model is performing. So if we see the accuracy for our model here, the accuracy is 0.72. It means basically it's a 72% accuracy. So the way we can interpret it is, so let's say we have 100 events. So out of those 100, our machine learning model, like SVM model we have built, is able to correctly classify the theme for 72 of those 100 events. But again, there is a problem